what's the coordinates of that point? This is a little graphing calculator. Did you guys get the graphing calculators at the library?
Yeah.
Did that work out? They there? You want to take advantage of that? I just yesterday somebody told me there were still 30 left. So if you haven't got that, great, free, completely free. Go to the library, check out graphing calculator. You need, absolutely required for the class, graphing calculator, right? You don't want to buy a $100 graphing calculator. You won't ever use it in calculus. You don't want to do that, right? So go to the library, check out a graphing calculator. Where in the library? Just the main counter? Is that where you go? Is that where it was?
It was the room on the left side, like right by the computer lab.
Right by the computer lab?
Like if you go in, there's a computer place, and then if you turn to the left.
Oh, down that hall to. Oh yeah, I know. Yeah,
But if you ask, they'll just tell you.
Just go in the media center entrance, basically, and go down that hall to the left, just past the computer lab.
No, not the down the hall. If you go into the library, then there's like the little room where computers are.
Okay.
Not in the computer lab, but there's like another little room with computers, and if you turn to the left door, that's where you go into.
So on the left. So just ask around, yeah. But anyway, get that. Definitely save your $100 on that. You don't want to purchase one of those because you're not going to use it in calculus, right? It's really just for this class. So take advantage of that. There's still 30 of those left. Absolutely required for the class. You won't be able to pass the test without it because there's questions that require graphing calculator. So here we go. Graphing calculator screen there. They're basically saying, all right, suppose that's a calculator screen. What does X min and X max mean? Do you understand what that means? Yeah, so that's right here, isn't it? That means this dot is negative 10, and this dot is positive 10 on the x-axis. And y min, y max, this is the y-axis, the minimum, the lowest y value is negative 10 right here, and positive 10 up there, isn't it? Make sense of what it's saying? X min means left edge, x max right. So left and right of the x-axis, y min, y max, bottom and top of the y-axis. Okay, so we do that first off. That's how it'll work when you're graphing things. You'll be setting up your window. And so if it puts a dot right there, let's figure out how big each of these jumps are. If I start right here in the middle and I go 1, 2, 3, 4, 5 jumps to the right, I end up at the number 10. So 5 jumps to the right gets me to 10. So how big is each of those jumps?
2.
They're each 2, huh? So I must be going by 2s. 2, 4, 6, 8, 10. And the same thing in the negative direction. Negative 2, negative 4, negative 6, negative 8. When you go up, it's the same thing, isn't it? So they're going by 2s also. 2, 4, 6, 8, 10. The very top there. I'm going to sneeze, I think. Maybe not. Okay, thank you. 10 all the way to the top there. And same thing, negative. So, with all that said in mind, what are the coordinates of that point?
Negative 6, 2.
Yeah, can you see it's back 6 up 2, right? It's back 6 up 2, isn't it? That's all they want. There's the answer to that question. That good? Just getting the coordinates. This is probably a little easier section than the last one. So, all right, so they're giving us a bunch of points here that we need to graph, say on a graphing calculator or whatever, and they're saying which of this, like this or this or this or this, which of those would be a valid setup that would allow you to see all these points on the screen? Which of these windows, these are all window setups, would be big enough window to see all those points? So, for example, this one, what would it mean about the window? Well, X min means left edge, negative 9. X max, right edge, right? X min, X max, X axis, left and right. Maybe I should put it like this, minus 9, plus 9, like that. The Y min is negative 14, and the Y max goes up to 6. Don't worry about the scale. That doesn't matter at all. That's how big the jumps are. We don't care about that at all. So would the point negative 13, 4 be on that screen?
No.
No, back 13 would be somewhere back here, up 4. It'd be a dot like about right there, wouldn't it? Because it's back more than 9. This is back 9, and it's back even more. It's back 13. So it's not on that in that window. So that's not the answer. Let's go to the next one. Is this one far enough back? Yeah, that one goes back to negative 14 now. The second one, negative 14. So that one would be on the radar. That wouldn't be in the window. And over to positive 6. right? The x min, the x max. See what I'm looking at there? Left edge, right edge. And then the don't worry about the scale. That's just how big the jumps are. We don't really care about that right now. We're just looking for total window size on this question. In a minute, we'll worry about scale for another question. But right now, we don't care how big the jumps are. We just care how big the window is. So -9 on the y. Erase these. So -9 on the y and +5. So would that window work for all these points? Back 13, up 4. Will that one be on the window? That one works, right? Back 13, up 4 would be about right there, wouldn't it? Right there. Back 13, up 4. That'd be in the window. How about the next one? 5, -7. Over 5, down 7. That'd be about right there. That's in the window. How about the third one? Back 2, down 8. Back 2, down 8. Yeah, it'd be about right there, wouldn't it? It doesn't go below -9. So yeah, that's the winner. I don't even need to look at the other two. This window is big enough to include all those points in the window. Is that good? Just making sure you understand window settings on a graphing calculator. All right, so they're asking me for x min and x max and x scale, which means how big the jumps are. So what's the x min for that graph? Yeah, that's right. Right there, huh? -12. The x max is regular 12. It's right there. And then what's the x scale? Meaning how big are the jumps from line to line? From here you go 1, 2, 3, 4 jumps to the right. 4 jumps to get to 12. So each jump must be 3, huh? That makes sense. Must be 3, 6, 9, 12. So each jump is 3. The scale is 3. That's what the scale represents. And then they're going to ask you the same thing for y, but I'm going to skip it. We good on that?
Yep.
That okay? Stop me if you have questions. Okay, so this one is giving me an equation, y equals x squared minus the square root of x. And they're asking me which of these points would be on the graph of the equation. We're not going to actually draw the graph or ever see the picture. But without even seeing the picture, we can, and I think you already know, figure out whether those points are on the graph or not. What do we do? How do you know if a certain point would be on the picture or not without even seeing the picture? What do we do? Plug them in, substitute them in. See if it makes it true. That's the membership requirement, right? Are we all clear on that? Like if I don't even know what this graph looks like, but let's suppose it looks like this. Woo, there we go. There's the graph. So suppose that's really the graph. Any point, and what is a graph? A graph is a million points, just all over the place. That's what a graph is millions and millions and millions of points. Okay, and all those points, it's like a big light bright. Remember that old toy, light bright? That's how you want to think about graphing. That's really what graphing is a bunch of individual lights light up producing a graph. Well, why do those lights light up? What makes a certain light get able to light up? And why right here, why did that light not light up? Why is that one in the dark, Well, it's all about whether the two numbers, the coordinates, I say like this dot right here, he's like over something, up something, isn't he? Maybe he's over 3, up 4. I don't know, I'm just making it up as I go along here. Maybe he's over 3, up 4. Maybe his x is 3 and his y is 4. He's 3 on the x-axis, up 4 on the y-axis. Maybe. So if he really is part of the graph, if he really did get to light up, that means he makes the equation true. Meaning when you put the 3 and you plug the 3 into the equation for x, that'd be like right here and there, and you plug the 4 in for y, it makes it true. Anything whose x and y make it true gets to be on the graph. Any point that does not, their x and y do not make it true, do not get to be in the graph, right? So that's the membership requirement. So now it's not really 3, 4, it's these other points. So let me go back, erase all that. So yeah, so our job then, without even seeing the picture, we're going to say, well, if you have the equation y equals x squared minus root x, does 1, 0 make it true? We'll test them one at a time. So that would be the x and the y. So put the 1 in for x both places and put the 0 in for y. Let's see if it's true. 0 equals 1 squared minus the square root of 1. I think that's going to work, huh? 0 equals 1. Square root of 1 is just 1, huh? 0 equals 0. Yes. True. So that means 1, 0 really would be a point on that graph. You know, I'm not going to draw the picture, but I know that over 1 up 0, that dot right there, at over 1 up 0, that must be a dot on the actual graph of this equation. So that's got to be true. Let's try the next one. How about negative 1, negative 1? Is that one going to be on the graph? Well, x, y, plug them in. Let's see. Well, actually, you know, really we're done at this point, huh? Look at the multiple choice options. It's 1, 0. It can't be negative 1, negative 1. And it can't be none, because we already found one that is. Really, you could answer the question now and move on. We know negative 1 is not going to work just from their options. But let's go ahead and do the formalities anyway. So y equals x squared minus root x. Plug in negative 1 for x in both cases, and negative 1 for y. Negative 1 equals negative 1 squared. Remember, you put parentheses around things you plug into formulas. Like that. Good so far? So is that true or not? Negative 1. Negative 1 squared, you know, is positive 1, huh? Now, what about these two negatives? Can they cancel each other out? Well, no, because that square root's in the middle of them. If the negatives were right next to each other with no root in the middle, then totally, they'd become positive. But with that root in the middle, you can't do that. You can't cross that barrier and let the two negatives get together to make positive. They don't get together. So, okay, what's this then? They've got to stay separate, so okay, I'll keep them separate. What is the square root of negative 1? It's imaginary. Yeah, it's not a real number. You have your calculator, you can square root of negative 1, it'll be air. It's not real. Remember, you remember that kind of stuff from algebra, maybe? Square root of 9, let me just give you the reasons why. Square root of 9, we all know is 3, as we all know. And what if a young child, a 10-year-old or something, asked you, why is the square root of 9 3? You'd say, well, don't bother me, kid, just do what I say. No, you wouldn't say that. You'd say, 3 times 3 is 9, right? You're saying, that what number times itself is 9? 3 times 3 is 9. So with that same line, and then that's correct, that's the right way of thinking about square roots. So with that, that's a negative 1 there. So with that same way of thinking, do you see why negative 1's impossible now? What number times itself, right, that's what square root asks, what number times itself is negative 1? Well, nothing. You can't have negative 1 times negative 1. That'd be positive 1. You might think, well, let's do negative 1 times positive 1. Yeah, but that's not times itself. That's times the opposite. That's not allowed. That's not what square root asks. Square root says what number times its very self? Nothing. No, not real. It's not real. That's why we say it's imaginary. So anyway, the point of all this is, does negative 1 equal plus 1 minus imaginary? Well, no. No, you can't. No, this is no. It's imaginary. It's not true. It's imaginary. Imaginary things aren't true, right? So that's just no. So, all right, so enough with that one. So we already figured if you tested the 2, 2, you'd find out it doesn't work either. And the only one that works is the 1, 0. Just plug them in. All right. All right, so we all good with that again. So again, here, and here are the X intercepts. 2, 0, and minus 2, 0. So that's the answer right there. What are the Y intercepts?
Nothing.
No, there's none. So we would choose no Y-intercept. Why? Because the graph, if it went through the Y-axis or something, then there'd be a Y-intercept, right? But it does not hit the Y-axis on that. Good on that. Now, if you're ever reading a question, if you're reading this question, here's what. Okay, so let's do this. This one more where we're going to find all the intercepts, which is all the places that the graph hits the grid lines. So I'll come in here, and I'll say it's right here. Oops, come on. Right there. Right there. Whoops, I missed one. Right there. And right there. All those points, huh? So what's the coordinates of this point? Back 7 up 0. Coordinates to this point?
0, negative 2.
Yeah, we good with that? Remember, it's always over first, then up down, right? So that's 0, negative 2. This point, over 1 up 0, and this point, over 6 sub 0. So what they want you to do then is list all of these, any order, it doesn't matter, with commas. Like that. That's what they want. Make sense on that? List all the intercepts. Graph lines. Well, first off, why is it a line? How about that? Y equals x plus 2. How do you know? I mean, there's the answer. That helps. But if the answer wasn't there already, that answer's already filled in for us. But if the answer wasn't already there, it won't be there when you do your homework. How would you know, first off, that it's even going to be a straight line instead of like a U shape or some other kind of curvy thing? How do you know it's a straight line? How do you know when you look at an equation that the picture is going to be a straight line and not have any curving in it, any bending?
It's in standard form.
Because the letters are both to the first power. And there's nothing weird like square roots or absolute values. See, if that was x squared or if it was y squared or something like that, then there would bring in curvature to the graph. It's the higher powers that make things bend in a graph. If it's just x to the first power and y to the first power, and there's nothing weird like no square roots or absolute values or anything like that, if it's just straight x, straight y, first power, it's going to be a straight line. We call that a linear equation because the picture is a line. So that's a linear equation. Okay. So now how did they come up with this? I mean, how do we graph? So it's a big deal to know that it's just a straight line, because if you know it's just a straight line, that means you only need 2 dots, huh? That's a lot easier. Whereas if it was curved, we would need a lot more than 2 dots to get the picture. But if it's a straight line, if we can just get 2 dots, then just connect those 2 dots, we have the picture, the straight line. So it all comes down now just to finding 2 points. Do you remember how you can, one easy way, there's a lot of ways. You can make tables, like make an XY table if you want. I'm just going to do that right there is one of the points. Have you seen that method? I'm going to start right there with that one. So that one is up 2 in the middle. If it was a minus 2, then it would be down 2 in the middle line. That's what we call a y-intercept, right? That's where the line goes through the y-axis. So whatever number's off to the right, that's 1 dot for sure, always on the middle line, positive up, negative down. And then how do we get a second point? Yeah, the slope. What is the slope?
Right
And what is it for this particular one? It is 1 over 1. Does everybody see that? Right? Because 1 over 1 doesn't change anything, right? I made it look different without being different, right? Plastic surgery, I always call that. We remove the wrinkles, but it's the same value it was all along, right? 1 over 1 is just 1. 1 times x is just x. I haven't really changed anything. And now I've helped myself because I needed a couple of numbers to be slope. Remember the fraction in front of x? Remember that from your algebra days? That's your slope. That's rise over run. So then we go from this dot, I can go up 1 over 1. Like that. There's my second dot. Connect the dots. That's how they got this line. See how it's at 2, then up 1 over 1. There's the other point. It's exactly what they did. Is that good? Remember graphing straight lines? This, by the way, all this only works if you get y alone, huh? You got to have y alone for this whole, find the first dot, rise and run, second dot to work. Good? Okay, so there again, there's the final answer. But suppose we didn't have that. They're giving me the equation y equals 2x minus 6. And they're saying start with x negative 2. So if I start with x, they basically want me just to plug into the formula, right, and get y values that go with it. You've seen this kind of thing before? So I just take this and I plug it in right there. So y will equal 2 times minus 2 minus 6. Y will equal what? Minus 4 minus 6. Y will equal minus 10. So that's the point back to down 10, x, y. Like that. See what I did? I just plugged the negative 2 into the formula. So then on the graph, that's this dot right here. Isn't it? Back 2 down 10. And then you do the same thing for 0 and the same thing for 2. And you'll find this dot and that dot. Is that good? You remember all that from algebra? Plugging in points and finding dots and all that? All right. Y equals x squared minus 10. What's that graph going to look? Is it going to be a straight line?
No.
No. When you have x squared, that's always a U shape whenever you have x squared, if just x is squared. And did you know it's all about the sign in the front? If right in front of the x squared is nothing, which means positive, right? That means the U shape's going up. So if you have positive x squared, the U shape goes up. If you have y equals minus x squared, then the U shape is going down. So we know because there's nothing or plus in front of the x squared, this one, right? That what's the answer? Right now we can tell the answer, actually. We don't need to do anything. It's that one, isn't it? That's the only U shape going up. Right? The other two are straight lines, and that's a U shape going down. So we're done. But let me do a little more than that, in case they made it more tricky than that. We can already tell the answer. So it is that one, that's true. What if they had a couple of U shapes going up? You know, and how would we tell a little more specifics than that? Well, you'd have to make an XY table. So I'm going to make an XY table. You can always do that, right? You can always get some points that make it true, like the light bright kind of thing. Find some points that make it true, so then they're on the graph. So now, well, what points? Plug in anything you want for x. What's the easiest number you know? Yeah, it's the easiest number I know too. 0. Plug in 0, right? Just because it's easy. You can plug in anything. So, and then I go, okay, y equals 0 squared minus 10, which is minus 10. So that means over 0 down 10. See, that's how they got that dot right there? Over 0 down 10. Now, what else? We'll plug in like 1. Because that's the next easiest number I know. 1 squared minus 10. What's that, minus 9? So anyway, on you go. You could get some particular dots, as many as you need to be able to tell which one's the right graph. Does that make sense on that? Mm-hmm. All right. So we've got y equals minus x squared plus 10. And they're saying plot the point for x equals negative 3. Do you guys want to try that? Let me give you a second. Go ahead and plug in negative 3 there. But remember, be careful when you plug into the form. You got to put parentheses around the negative 3 as you plug it in there, right? So if you plug that in, so minus 3 squared is 9, huh? Whoops, kind of scribbly there. And so y is positive 1? That good? So it'd be the point minus 3 up 1. Because x was minus 3, y was 1, x, y. Good, remember all that stuff? Is that okay? And then they just have 8 more for you to do. Sorry, that's kind of a long one, 8 parts. So they're just going to have you keep plugging in points, I guess. All right, I'm going to move on. I don't think that'll be hard. Is that okay? You guys are giving me the poker face. You can't give me the poker face. Yeah, maybe I'm doing that. You got to give me the, I don't know what you're doing, Mr. Herring. Kind of shake this way or shake this way. Then I'll know I can speed up or slow down. Okay, so minus 4x plus 3y is minus 12. Okay, so I want to graph it. Is that one going to be a straight line, or is it going to be one of those U-shapes?
Straight line.
Yeah, we know it's straight line because x and y are just first power, huh? Nobody's squared, so we're already down to 2 options, huh? Anyway, so how could we graph it? You could make a table if you want to. I think I'm going to do just the solve for y thing. Go ahead and do whatever you want. When I do it, I'm going to get y alone. I'm just going to get y alone and do what I did last time for the line. But if you want to just make a table, that'll work too. Get a couple of dots. However you can get a couple of dots will work. So to get y alone, I'm going to add 4x. Like that. So far, so good. And then divide through by 3. And 12 divided by 3 is 4. Like that. 4/3 x minus 4. Now, let's graph that thing. Now that we got y alone. So where do we start?
-4.
Yeah, that number out there is down 4 in the middle, huh? Whatever number's out there. So I'll just say, okay. So 1, 2, 3, 4 right there. That's your first dot. That number off to the right just tells you your first dot, your y-intercept. And then, you know what the rest is. It's rise over run, huh, for this. So I don't have to put 1 over 1 this time because I already have a fraction in front of x. If there was nothing there, I'd put 1 over 1 again, right? So go up 4. 1, 2, 3, 4. And over 3. Whoops, we're messed up now. 1, 2, 3. There it is. I went up 4. Over 3, connect the dots, there we go. So which one is it? It's this one, huh? Good? Remember all that? All right. Okay, so 2x squared plus 9y is 18. Is this going to be a straight line or one of those U-shapes?
U-shape.
Yeah, x is squared, so it's going to be U-shaped. You can do whatever you want. You can just get some points. You know, you got to know which of those. I'd probably just get y alone again. That's probably what I would do. Just get y alone and figure out which of those U-shapes it is. So here's the wall. So I'm going to subtract 2x squared. Like that. Later we'll get more formal with all this. We'll about 2 months, maybe a month and a half, 2 months, probably 2 months. We'll do a whole section on U-shapes. We'll even turn them sideways. We'll find their focus points and their lattice rectum points and all these fancy things. We'll get really technical with them later. But for now, we're just kind of, this is just like an intro section, just kind of getting our feet wet, just keeping it kind of casual, just making sure you can find points and generally know what the graph's going to look like. Specifics are coming later. So to get y alone, divide by 9. And so we get y equals minus 2 9 x squared, and that's just a 2 out there. Really, I have enough information right now to know which graph it is, huh? What does that negative sign mean? It's U-shape going down, huh? Down. It's a U down, so it's that one. You could plug some points in if you want, but why bother? I already know which one it is. Right? That good? On that? Yeah.
On the test, will we have to do the graph?
Yeah, good question. You can look at the practice exams, but of course I might be changing things. So let me hold off on that answer. I'm not sure. Yeah, I have practice exams already on the first page of Math Excel under the announcements, but I might change that up a little bit. So I'll let you know. Try to let you know next week. Good question. Okay, so we have on number 22, y equals 13x minus 20. And we're trying to find the intercepts. What are the intercepts? Well, the intercepts would be like, you know, if the graph goes blah, 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 you know, I have no idea what the graph looks like. I'm just oh, it's a straight line, huh? Yeah, so it's not that. But anyway, whatever. So yeah, maybe I should at least make a straight line. I'm not even close. So it's some kind of a straight line that does something like this, right? And I'm trying to find these two intercept points, right? That's what they're asking me. They're saying find the two intercept points. Find the two places that the straight line graph hits the grid line. So those are intercept points, right? So how do you find those 2 points? What do you do? Yeah, do you know you plug in zeros for x and y? Are you aware of that with intercepts? At an intercept point, one of the two coordinates is always 0. Do you know that? Like, let me show you what I mean. Like, what's the coordinates of this point? Well, I don't exactly know, but I do know part of it. I know it's over 0, and then I don't know how far down. And this one I know is over, I don't know, but up 0, huh? It's got to be, right? See, when you're on the grid lines, one of your numbers has got to be 0, doesn't it? That's what it means to be an intercept, to be on the grid line, right? This dot, if he's really on the line there, is up 0. His y coordinate. Notice he is an X intercept. He's hitting the X grid line, and his y coordinate is 0, right? And this point is hitting the y axis, and his what? X coordinate is 0. So the opposite letter is 0 when you're on a grid line, right? You agree with that? When you're on the y-axis, your x coordinate is 0, because if you're on the y-axis, your right and left 0. And if you're on the x-axis, you're up and down 0. Your y coordinate is 0. So with that in mind, if they give me an equation, they want me to find intercepts, I just say, oh, I'll just make the opposite letter 0. Plug that in and I'll find it, right? If you want an x-intercept, make y 0. You want a y-intercept, make x 0. And you'll find it, right? From the picture, we can tell that's true. So let's do that. If they want me to find an x-intercept, I'm going to set y to 0. So let's do that. Take y and pop in 0 there. What do you got? 0 is 13x minus 20. We okay? And then solve for x. Everybody good so far? So how do I solve for x? Just add that 20 over, right? To both sides. And we get 20 equals 13x. Last step to get x alone. Divide by the 13. Boom, x is 20/13. So that must be the x-intercept, 20/13. I guess I should have started with the y. They want the y-intercept first. So I'll do the y-intercept now. So now to find the y-intercept, so that this was all the x-intercept. Now for the y-intercept. So y-intercept, I'm going to set what? X to 0. Good. Set x to 0. So when you set x to 0, put 0 in right there, you get negative 20. So there's the y-intercept. So the y-intercept's way down here at negative 20. The x-intercept is over here at 20/13, which is like 1.5 basically. Good on that? That okay on fine? So we didn't need the calculator, did we? We didn't need the fancy graphing calculator to graph the whole thing for us and use the table feature and all that blah, blah, blah. I mean, you'd need the calculator to divide 20 by 13 because they want a decimal, I think. Yeah, 2 decimal places. So for y, the first one, this is just y equals negative 20. But for part 2, when they ask for the x-intercept, you're going to have to take 20 divided by 13 on your normal calculator and get the decimal. Is that good? But we don't need to use the fancy graphing calculator. Not yet. That's coming. Questions on that? Is that okay? So how do we find, and so the rest of these questions are all the same thing. How do you find an intercept? Well, to find an x-intercept, you make y 0. To find a y-intercept, you make x 0. You make the opposite letter 0. Just plug in and solve. On to our next section. Okay, so 7x squared plus 3y is 59. Okay, so let's start by finding the x-intercept. Oh, wait, are they asking? No, they just want the graph. They just want the graph? Oh, my mistake. They just want the graph. Yeah, so you know how to find the graph, right? I'm not going to use the graphing calculator. What am I going to do to find the graph? I'm just going to get y alone. So y is over here saying I want to be alone. So I'll subtract the 7x squared from both sides. And then I'll get, what is that? 3y is minus 7x squared plus 59. Good to there so far? We okay? Can you already tell that it's a U shape going down? So it's either this one or this one. It's one of those two, isn't it? How do we know which one? Well, we got to find a couple of points, don't we?
Divide everything by 3.
So, yeah, let's divide through by 3. Like that. Is that good? So y is minus 7/3 x squared plus 59/3. Now, how do you know which of those two U-shapes going down is the right one? I think we can find it by just one point. If we just say, hey, because see how the middle dot is up high on this one and the middle dot's right smack in the middle on that one? So which of those is right? A. Because if you plug in, if you set x equal to 0, which means you're on the middle line when x is 0, right? Then to this equation, you plug in 0 there. You see, you're gonna get 59 thirds, aren't you? So it's A, because it's up high. Whatever 59 thirds is, I don't know, 20, just under 20, 19 and 19.666, I think. It's up high, right? It's not at 0, 0, is it? So this is not right. So there we go. That's all you need to do. Just get y alone. You know it's a U shape going down. You figure out which one by just plugging in x to 0, and you've got it. Yeah. Good on that? We good with all those? The only one I'm not sure, 23, because that can be a little tricky. And we'll be done with this section. All right, so they're giving me y equals 11x squared minus 16. I'm not going to do the y-intercept is cake. Can you tell me, what's the y-intercept? Negative 16. Does everybody see that? The y here, I said I wasn't going to do it, now I'm going to do it. Y-intercept, set x, this is what I always do. I do too many easy ones and then I run out of time for the hard ones. All right, y-intercept, set x to 0, right? Just pop in a 0, that's cake, huh? So clearly y is negative 16. So that's the easy part. That's the part I didn't plan to show you. Now, let's find the x-intercept. That's a little more tricky. So on this one, the x-intercept, you know, that means set y to 0, right? Intercepts always set the opposite letter to 0. So y-intercept, make x 0. X-intercept, make y 0. So make y 0, take the equation, and plug in 0 for y. We good to there so far? Trying to find the x-intercept, so I made y 0. Now I need to solve this equation for x. Do you remember how to do that? Remember how to solve that for x? What do I do to solve this equation for x? Start by adding that 16, right? We okay with that? Just want to make sure you're okay with this. And we get 16 is 11x squared. The next step, divide by 11, like that. And so, I'm kind of running out of room here. I'm just going to get rid of this stuff. And then come over here. Everybody good to there so far? How do I get regular x now? Square rooted, exactly. And do you guys know what are you supposed to do when you square root both sides? Good, I'm impressed. Yeah, do you know you're supposed to put plus or minus? You can't just square root, you've got to put plus or minus, because there's actually two answers, right? For x squared, you can put positive or negative in there to be squared and come out 1611. So, yeah, and they just probably want a decimal. So at that point, just hit the buttons on your calculator, decimal, you're going to positive. I got my calculator. Here, I'll do it too. So it's the square root, square root of 16 divided by 11. So I'm getting plus or minus 1, how many places they want? 2. 1.206, so that'd be 1.21. Plus or minus 1.21? Is that good on that? Does that make sense? I don't know if they want you to enter like 1.21 comma negative 1.21 or whatever they want, you know. Probably like that, however they want it entered. Good? All right. I'm going to leave that behind.